Hi, today we're going to be solving quadratic equations again, but this time we're going to be using a different technique to do this. And before we start that technique, let me give you some background. In order to solve question 1, x squared equals 25, the only thing in our way is that power 2. If I can get rid of the power 2, then I can get to x. And if you recall, getting rid of a square power, you would take the square root. But don't forget that when you take the square root, you actually have two answers on the other side. And that's the common mistake students forget, is that you have a positive root and a negative root. So you're going to get positive or negative 5. That positive negative 5 means x equals 5 or x equals negative 5. All right, problem number 2, same idea. X squared equals negative 25. Well, again, I just have to get rid of the power 2 by doing the square root. Don't forget that I have two roots, positive and negative. And recall that if you have a negative number under the radical, you will have an I. So radical negative 25 is 5i. So the answer is plus or minus 5i. So that means that the answer to that, they have two imaginary root answers for the answer to number 2. Okay, and then number 3, how would I solve problem 3? Well, on problem 3, you could do this problem by, and I'm not going to, but I'll just start it. You could do this problem by doing x plus 1 squared, making it x plus 1 times x plus 1. You could go through the whole distributive property, combining like terms and all of that, and that would work. But there's a much quicker way. My goal is to unravel it to get to this x. And right now what's in my way is a power 2. So instead of getting rid of the power 2 by actually doing double distributive, I can get rid of the power 2 by doing the inverse operation, which is square rooting. So that means I'll get rid of the power 2, and you'll be left with an x plus 1. And then don't forget that when you square root the other side, you have a positive and negative 5. And now all I have to do is subtract the 1 over. So recall that positive 5 and negative 5 implies that there are two answers. So first I'll write it like this. It's negative 1 plus or minus 5. Now I can split that up so I can actually see the numbers. You have two options. You can either add 5 or you can subtract 5. So I will do them both. Negative 1 plus 5 means one of my answers is going to be 4. Negative 1 minus 5 means one of my answers is going to be negative 6. Okay, and one last thing, background. 4a, how do you expand x plus 3 squared? So if you recall, I just showed you x plus 3 squared means x plus 3 times x plus 3. So if I double distribute, I get x times x is x squared. X times 3 is 3x. 3 times x is another 3x. And 3 times 3 is 9. Combining like terms, you get x squared plus 6x plus 9. Now this right here, this quadratic, it's a perfect square. A perfect square is anything that can be written in the form something squared. And if you go back, that's what the original problem was. So x squared plus 6x plus 9 is a perfect square. So when I'm solving a quadratic, if I can get the quadratic to be a perfect square, then I can write it like I did in 4a, and then I can solve it like I did in problem 3. So in order to make x squared plus 8x be a perfect square, what would have to be the adding number right here? Well, I know that I need two of the same. All right. I know that my outer 2 and my inner 2 have to add up to equal 8, but they have to be the same. So in order for me to add up to make an 8 but still be the same, it has to be a 4. So what's the last number? The last number is going to be whatever the 4 times the 4 is, and it's 16. So if that number were a 16 that I added there, then this would be a perfect square quadratic, and I can write it as x plus 4 squared. Okay, so we're going to use the ideas on this Use What You Know page in order to learn our second method of solving quadratics, which is to solve by completing the square method. Okay, so in order to solve a quadratic, I'm going to first go back to basics and do it by the factoring method. All right, in order to factor this is a trinomial that begins with a 1. So it multiplies to negative 20 and adds up to positive 8. And the one that does is negative 2 and 10. So I can factor this one easily by just doing those two numbers. I don't have to go through the AC method on this problem. Setting both factors equal to 0. And I get my two answers of negative 10 and 2. So now we're going to do a different algebra approach. We're going to do it by completing the square. And what this entails is doing what we did on the Use What You Know. I actually want to create a perfect square quadratic. So in order to do that, I first have to clear everything out of the way. I need to get the x squared and x buddies together. I need to kick him over. So I have to add the 20 over to get him out of the way so I can complete the process. All right, so I'm going to leave a little space right here, because what I have to do is figure out what can I add to that side to make that a perfect square. Now that 20 is out of the way, I can just have them off to the side. So again, what do I need to add to make that a perfect square? Well, there is a way to do this without trying to keep on guessing and checking. And if you notice in number 3, the number that you're going to add to make it a perfect square is going to be equal to the b number split in half and squared. Okay, because 8 split in half makes our 2 4s, and our 2 4s multiplied is 16. So if you can figure it out without doing this, that's great, but this is the direct way to get that number. So if I take the 8 number, split in half, and square it, I get 16. So if I add a 16 here, this side will be a perfect square. Now you can't just magically add 16 to one side. All right, just like if we were on a teeter-totter, if things were balanced and I add 16 pounds to my side, I would have to add 16 pounds to your side if we were already balanced. So you have to make sure you keep the equation balanced by adding 16 to both sides. So again, we're not doing anything horrible. As long as I do the same thing to one side as I do the other side, it's still the exact same equation. I'm just changing what the equation looks like. Okay, now the x squared plus 8x plus 16, that's a perfect square, which means that I can write it as something squared. And the other side is just 20 plus 16, which is 36. All right, so x squared plus 8x plus 16 is going to be x plus 4 times x plus 4. So I can just write that as x plus 4 squared. All right, now the reason to go through all of that is because now when it is a perfect square, I can just unravel the pieces. All I have to do is get rid of the power 2, and then after I get rid of the power 2, I have to get rid of the plus 4. So in order to get rid of the power 2, we're going to take the square root of both sides. Don't forget to do positive and negative of the other side. A square root of a square will just drop the power 2, so you're just left with the x plus 4 piece. Positive and negative square root of 36 is positive and negative 6. Okay, now all I have to do is get rid of the 4 by subtracting the 4 over. And again, I know it doesn't look like the answers yet. We know the answers are going to be 2 and negative 10. Because I have two whole numbers, I definitely want to split this up. So one answer is going to be negative 4 plus 6, which is my negative 2. The other answer is negative 4 minus 6, which is our negative 10. And I know this may seem like this is harder. Obviously, factoring, that was an easier method on this particular problem, but there are times where the completing the square method might be easier, especially if it can't factor. You have no choice but to do completing the square up to this point. In next class, we're going to learn a new technique also that deals with solving quadratics. So from here on out, I am just going to do it by the completing the square method. All right, completing the square method. I need to get the x squared and x buddies together on one side. And I need to kick out everything, the other numbers to the other side. So subtract the 27 over. Okay, I'm going to leave a spot because I know if I'm doing this method that there's something I have to add here to make this a perfect square number. And the number that's going to make this a perfect square, and again, some of you may know, but you take negative 12, you split it in half, and you square it. And that's going to make 36. Now, because you're always squaring, don't forget a squared number is always positive. So if you forget your parentheses, you're going to get a negative 36, so you should know something's wrong. Okay, so adding 36 to this side will make the left side a perfect square, but I also need to add it to the other side to keep the equation balanced. All right, the left side is now a perfect square. That can be factored into two of the same guy, and it's going to be x minus 6 times x minus 6. So that means x minus 6 squared. All right, and 27 plus 36, that adds up to 9. All right, all I have to do now is get rid of the power 2 and get rid of the negative 6, and we solved for x. So square root both sides to get rid of the power 2. That's going to drop the power 2. And positive and negative 9 is positive and negative 3. Okay, we're going to get rid of the subtract 6 by adding 6 over. And you get 6 plus or minus 3. All right, splitting these apart. 6 plus 3 is 9, and 6 minus 3 is 3. Now, anytime you get answers that are both whole numbers, it means that the original problem could have been factored. But as I already told you, not all of them can be factored, which is where you're going to about to see. So if we go to problem 3 now. Problem 3, you cannot factor that. So you would have no choice but to do this method. Also, please note that if you can't factor it, you will get answers that are not pretty. Okay, so bringing over the 6 by adding, because we need to get the x squared and x buddies by themselves on one side and the other number on the other side. We just need to get him out of the way so we can make it a perfect square. So all I got to do is figure out what to add here to make this side a perfect square. So I take negative 4, which is my b number, and I divide it in half and square it, and that's my magical number that'll make it a perfect square. That will come out to evaluate to be a 4. So I'm going to add 4, and it's always going to be an adding number because, again, you're squaring the number. Okay, so x squared minus 4x plus 4 is a perfect square. It means it can be factored into two of the same parentheses. It's going to be x minus 2 times x minus 2. So it's x minus 2 squared. That's our perfect square. Okay, all I have to do now is get rid of the power 2 and the subtract 2 on the inside. Square rooting will get rid of the power 2. So you're going to have x minus 2 left on the left. And you're going to have positive and negative radical 10 on the right. Okay, so unfortunately, we can't get rid of that radical. Radical 10 does not reduce. It's not pretty. So you're going to leave it that way. all I have to do now is get rid of the minus 2 by adding the 2 over. And you're going to get x equals 2 plus or minus radical 10. All right, so this bad, ugly answer indicates the original problem could not be factored. And when it does not come out to be pretty, the radical, then we don't have to separate them. These are, in fact, your answers. You're going to see this form of the answer common. But if you really want to know, it really does mean that x is either 2 plus radical 10 or x is equal to 2 minus radical 10. But again, we don't normally unseparate them unless they're nice numbers, both of pieces. But you can if you feel like it. All right, example 4. This also cannot be factored. All right, so again, we're going to get the x squared and 6x buddies by themselves by subtracting the 10 over. So x squared plus 6x, leave some space, equals negative 10. Okay, so what do I have to add here? In order to figure it out, I have to take the 6 number, split in half, and square it. And I'm going to get 9. So if I add 9 to that side, I'm going to have a perfect square. Balance it out by doing it to both sides. All right, so this is now a perfect square, and that's going to factor to be 2 of the same, x plus 3 times x plus 3. So I can write it as x plus 3 squared. And then negative 10 plus 9 is negative 1. All right, getting rid of the power 2 by doing the square root. Don't forget positive and negative. The x plus 3 will be left, and on the other side, positive and negative square root of negative 1. There's our negative under the radical. You know, if there's a negative under the radical, this implies an I answer or an imaginary answer. So positive and negative, the square root of negative 1 is actually equal to I. Okay, subtracting this over. You get negative 3 plus or minus I. And you may leave it together. You don't have to separate them. Just to show you real quick, graphically, if you were to put this in your calculator, and graph it, and I'll put my 0 in there. And I'll bold it so you can see it. Okay, if you notice the two graphs do not hit each other at all. That is indicating that the answers are not real. They would be real if you did in fact have points of intersection. So that's a great way to double check yourself. This is the only time when you have I answers that you cannot do the graph or table approach because you don't have any points of intersections to look for. Okay, and last problem. Example 5. All right, so I need to get rid of the negative 12 because that's in the way. So we're going to add the 12 over. Okay, and I cannot complete the square unless this is a 1. The leading coefficient on x squared has to be a 1. Okay, needs to be a 1. So I have to get rid of that 2 or else I cannot do this method. Well, in order to get rid of a times 2, I have to divide 2. But don't forget that you have to divide the both sides by 2, and it's the entire side that you're splitting in half. All right, so if I'm going to remove half the weight off of one side, I have to remove half the weight off the other side. And you have to remove it off of everybody. So that is the only thing that kids make a mistake on is you have to make sure that this is a 1. So x squared minus 10x will be left on the left-hand side. I'll leave my space equals 6. Okay, once I remove that front 2, now I can go ahead and do my whole process. What do I need to add here? That's going to be the negative 10 number split in half and squared. And that's going to make 25. So I'm going to add 25 to both sides. All right, this is now a perfect square. It's two of the same. It's going to be x minus 5 times x minus 5, which is x minus 5 squared. And then 6 plus 25 is 31. Get rid of the power 2 by taking the square root. Don't forget plus and minus. The power 2 will drop on the left. Radical 31 is not pretty, and it can't break down, so I'm going to leave it. And then all I have to do is add the 5 over, and you get x equals 5 plus plus or minus radical 31. Now, if you really, really want to check, you can check. You, in fact, can use the table to check. Or you can do it on your home screen, and you can store. I'll do it by the table method. You put the left side of the equation in graph 1. Let me start over. X squared, 2x squared put a 0 in the bottom. I could do this by the graphing technique. I could get my points of intersection, but please note, I would then have to convert my two answers to decimal so I could actually compare that. Or I could go to my table settings and change my table to ask. And then I can actually type in, one of my answers was 5 plus radical 31. Remember, you can only put in a precise answer. You cannot put in a rounded answer. It will not check out. And you will actually see that that does check out. Now, if you go back up, you'll actually see what you, oh no, it did convert it to a decimal. Unfortunately, when you put it in, it did convert to a decimal, but that's okay. Now, don't forget the other answer is 5 minus radical 31. So this is a great way to do checks rather than your home screen, and you can see that that also checks out. Okay, so now you've learned how to solve radicals by factoring. And again, factoring method only works if it can be factored, like in examples 1 and 2. But if it can't be factored, like in examples 3, 4, and 5, you have no choice but right now to do the completing the square method. And next time in class, you will actually learn a quadratic formula that deals with all types of quadratic equations and their answers.